All right, here's 8-6, day 2. And we are going to do a little graphing, but it's going to look a little weird because we're going to graph in polar coordinates. We'll do 2 of them. So remember, when we've got points in polar coordinates, it's r comma theta. Okay, but here's, it's hard to relate it to x and y. If you want to think of it like input-output, theta is like the x. We put that into the equation to get r. So r is like the y, okay? We put them on polar coordinate graph paper, and it creates really, really different looking graphs. Right? You'll see flower petals today, and you'll see a cardioid. I think a cardioid looks like a piece of fruit. Looks like a peach, maybe an apple. We'll get to that one second. You can make circles with them. You won't see that today, but we will eventually. So let's get to it. Okay, first thing we would need is a table. And you can see I've picked all the angle values for you, so you would just need to plug those in. You could certainly use a calculator to help you out, okay? Pretty straightforward stuff that you just I'll write out basically the first one, okay? And then you could pause if you want to. Again, you could do it with the help of a unit circle or a calculator. I picked really nice numbers, right? Because I already filled in half the table for you. A calculator would work just as well. If you did, make sure, obviously make sure you're in degree mode. But for like the first one, I would take 2 times cosine of 2 times 0, okay? And I'd get 2. Right, for the next one, instead of 0, I would put 30 right there. And take 30 times 2 would be 60, cosine of 60 times 2, and you would end up getting 1. Okay? If you want to give it a shot to fill in the rest of the table on your own, this would be a time to pause. Okay? Give yourself a couple minutes to do that. If not, I'm going to go full speed ahead, and I'm going to get the rest of my table filled in. Just know that what you're seeing there in blue, right? I've kind of talked about 0 and 30. 45, 60, 90, 120. I would just go full speed ahead and just keeping that angle to the new value. Okay. Notice the numbers come out nice. I picked nice numbers. So from here, we're basically going to get a ton of practice graphing. Okay. So now I wrote R to the left because I think you want to start with R, right? 2, 0. So I go to the right to go to 2, and I just don't go anywhere, right? I just leave it right at 0. All right, so then I go to 1, and then I got to go to 30, which would be right there. 0, 45, right? Anytime R is 0, the angle kind of doesn't matter. You're not going anywhere, okay? -1, and then I got to go 60, right? This one can potentially be a little bit tricky, right? I go to -1, but then I need to go counterclockwise. So I actually end up there, okay? Here's -2, and I go to 90, okay? -1, and over to 120. Okay, I was thinking of that, like here's -1, and then I go that way to get to 120, okay? I'm being a little bit more particular on my graph to keep it neat that I'm not writing that out. When we plotted points in the first day, I typically did write that out. And then we're back right on 0. Angle's 135, but that doesn't really matter. All right, where'd we leave off here? We're back at 1, right? So now I'm going to the right again, and now my angle is 150. So I'm right there, out to 2, and then over to 180. Now, if you wanted to kind of keep track of what's going on, this is if you want to label the example, this is a flower petal. I could connect all my points as I make them. That's what we have so far, right? I'm about halfway through. Now I'm back to 1 and go to 210. $225 is at 0. All right, so we're back to -1, and now we're going 240. Should have to go all the way around to 180. 210, 240 would be there. So now this will extend, kind of going to start my last petal. -2, right? So go left to -2, and then I'm going 3/4 all the way around to there. There's 270. -1, then I'm going to 300. $315 and back to 0. $1, then go around to 330. Which would be all the way to there. And 360 would be 2. Okay. So again, that was a flower petal. So if you have, just in general, because I did a cosine of 2 theta, you'll get 4 petals on the x and y axis. I didn't show you one here, and the next one's not going to be a flower petal. If you did sine of 2 theta, it would still be 4 petals, but they would be inside the quadrants. They wouldn't be like, with each one of those flower petals, you see how it's kind of centered right on the x and the y axis? Sine, they would still look the same, but they would kind of fully be within each of the 4 quadrants. Okay. So yeah, if you're expecting with graphing, to do like coordinate points and, what we're so familiar with, x and y, graphing and polar coordinates, the designs can be kind of cool and different, but really, really different stuff from what we're used to on graphing, okay? So here's the next one. We'll think about it in 2 parts. Okay, this one the numbers won't come out quite as nice. You can go ahead and round to the nearest 10th. Remember, calculator is still going to be the name of the game, right? So I'm getting R. Again, I've filled in half the table for you. So to get started, I would say 1 minus sine of 0, which is 1, right? Then I would do 1 minus. And if you want to approximate these from a calculator, I think that's the best way to do it. All right, I've got those first two, just like the last example. If you wanted to pause here and, see for, your own confidence, if you could go ahead and fill out the rest of the table, this would be the spot to pause. Otherwise, I'm going for it. Okay. Now it basically leaves us in the same spot as the last example. We have a bunch of points to plot that are obviously in polar coordinates. First point is at r equals 1, theta equals 0. That's right here. This is not going to be a flower petal, by the way. It's called a cardioid. I mentioned earlier, I think when you're all said and done, it looks like a peach or some kind of round piece of fruit. Okay? But you'll see. You can be the judge for yourself. All right, so 30 and 1/2 would be right here. .45 and 0.3 would be there. 60 and 0.1, 90 and 0. It's kind of doing this thing. Whereas the angle changes, it's kind of like zoning in on 0, more or less. Now we head off to, let's see where we at, 120. And it starts to move away again. 120 is at like 0.1. 135. We'll call it like 0.3. .50 is at 0.5. 180 out at 1. So now it's kind of like doing the same thing, but it's starting to move away. .210, let's see here, is right out here at 1.5. 225, 1.7. 240 out at 1.9. 270 is out at 2. So it goes through here, and it kind of does like the same motion, but now it really starts to widen out. .300, it was 1.9. .315 was down at 1.7. 330 at 1.5, and at 360 back to 1, so I'll connect those. And there you go. Again, I think it looks like a piece of fruit. But yeah, the technical term for that is a cardioid. If you were to do it with sine, your cardioid would be centered on the y-axis, as we can see in our graph. We do not have an example of cosine, but as you would guess from this pattern, I think, centered on the x-axis. it'd be like that same shape, but kind of just turned over on its side is what you'd see. So really what we're after here is kind of two parts. Could you use your calculator to put together your table? And again, on your homework assignment, expect, like, as far as the angles that you should put in, right? It's not going to vary. I'll fill them in for you, and these are the theta values you'll see. Can you get the table completed? And then what it's really doing is seeing how well you can graph points that are written as polar coordinates. Because that's really, when you look at these two examples, that's kind of what it was all about, was just tons and tons and tons of plotting points. Once you get the hang of that, which is what we're looking for to practice in this lesson, I think you'll find the graphs are not too bad to create.